Hello. Let me go over and explain for homework 5, the solution for homework 5, and we can look at that. So homework 5, uh, the problem we had was related to uh, uh, correlation and regression, which I mentioned, is one of the most common used and important in statistics and in evidence-based practice. You would look at relationship, for example, with age and blood pressure, relationship between glucose and your A1C. So all of those can be explained with correlation and regression. And so sometimes also you wanted to predict which the regression comes handy. So the first problem is we have number of hours of study and grade, and I ask you to calculate, look at the plot and also calculate correlation and do the test and conclude. Obviously the plot shows there is a positive linear relationship between the number of hours and grade. As you study more, your grade goes high. So that is the positive linear association is correct answer. To calculate your correlation, I give you this table. So using the formula, basically the formula for x, finding the SXX, SYY, SXY, you put the sum x squared, which is 190, minus first you sum and square it, 40 times 40 divided by 10, you get 30. So basically you calculate these three terms simple and then put it in the formula, and that gives you the correlation 0.992, which is the correct answer. And then the test statistics is just you using the correlation, which may some of you use just 2-digit, and your value was a little bit off from mine. I used 3-digit, and it comes 22.18. And here, this is your test statistics. You compare your test statistics to your critical value, and here is the t-table you're using, and with n-2 degree freedom. Again, anytime your test statistics is greater than table value, you reject your null and conclude there is a correlation. So, and the table, again, you look in the t-table, you have two sides. Tail you wanted to look at with 8 degree freedom is 2.3 or 6 comes from there. So since 22 is greater, then you reject and then you said yes, t-value, and conclude there is a linear positive relationship between hours of study and grade. So problem 2 is similar to problem 1. Again, you're looking at the plot and obviously going down here and then calculating Pearson correlation. Again, here we have using this table, you would calculate SX, SYY, SXY, and it comes negative 899, which I should have rounded to negative 90. And that's I use for testing, negative 899, and it came negative 5.8. And here, the table value, again, you're looking at TA8, and I said the alpha here is different. So the alpha, we wanted to look at 0.05. Again, it would be 0.975 here to look at with the alpha 0.1, you get 3.355 from table. So you find that, and you would reject your null or not, basically. So that was here. Again, the alpha depends the type of the alpha you're using. So in the problem, you have to use the right alpha. And again, the table, you can look at two-sided. If it's 0.01, you're using this one, 0.05, you're using that one. So 3.35 for alpha, 0.01 comes from there. Now, the experiment correlation was the one I added, and I give you the table. So basically, I ranked each column, anxiety and physical, from lowest to highest. Then I took the difference between those ranks, 1 minus 8. Then we square that, and then we add it up. So the sum D square basically is the total of these values, 314, and it came to negative 0.90 for the correlation. Problem 3, I asked you, we have a metric, so I asked you what is the highest correlation, and there are 3 correlations you have. Obviously was anxiety and smoking, so 0.8 was your highest. And I asked you to calculate the partial and semi-partial correlation. Just again, you have 3 terms here. Your outcome is your anxiety correlation anxiety, and your independent physical is negative 0.6 minus in formula outcome with smoking, anxiety and smoking in 0.8 times. Now the third term is anxiety and your again, physical activity and smoking, which is negative 0.4, and then you have those 2 terms you put it, and if you notice, I put it in parentheses, negative 0.4 become positive, so you get negative 0.51, and semi-partial, the difference was we just controlling for the effect of smoking from your independent variable, which was physical activity, negative 0.4, not from your outcome, which comes 3.306. Problem 4, we're looking at regression, simple regression, the same problem 1. We look at it. I asked you to find the prediction. Again, looking at the SAS output, this is your intercept, it's positive slope. So the prediction equation is 54.3 plus 5.8x, which is number of hours studied. That is your prediction equation, grade equal to that. So the plot of residual doesn't show any pattern, so that is the correct answer. And I ask you test if the slope is significant. Basically, you look at the p-value here. Since this p-value is less than alpha, you would say there is a significant. And then I ask you to report R squared and adjusted R squared, which is 0.98 here. Both of them, this is R squared, this is adjusted R squared. 95% confidence interval for beta. This is your slope. This is your standard error. Basically, using the formula 5.87 plus your standard error was 0.261. You just use 3 digits times 2.306. That is your 8 degree freedom and 0.975. So and so that is your you get 2 value 5.27, 6.47, which tell us we have 95% confidence our true slope is between those two values. And problem 5, again, we look at the anxiety and physical activity. Your prediction equation is negative because if you look at its negative value, the slope is negative here. And so adjusted R squared, adjusted R squared here is different, 0.81 and 0.78. So what would be the anxiety score if 85, you put 85 in that prediction equation, so you have 85, you put it in that equation, you get that is your intercept minus 0.87 times 85, you get 25.58. So your physical, your anxiety level score would be 25.758. So basically that was another problem for regression. Problem 6, we had multiple regression. Again, you had your outcome t-freak and you have your intercept, and you use this is your slope 0.68, I rounded for H minus 1.24 for T physics, physical activity, plus 0.13 social support and so forth. So that is your prediction equation. Again, adjusted and R squared 0.40 and 0.32, I rounded there. And prediction equation, basically you write your prediction and you replace those values for each variable, and you just simplify, you get 7244 for that problem. For factor related to health promoting behavior, what is statistical, the title tells you multiple regression. The outcome was total health promoting for table 3 and interpersonal relation for table 4. And if you look at the sort of table, you can see how many significant you have for white and black. So the question here, just going to table, and here looking at the p-value, so we set table 3. If you look at table 3, this is our table 3. So for white, we have Rosenberg significant, and we have perceived stress and social support less than 0.05. Social support is close, is 0.52, and 0.56. Health status is close too. And for black, if you look at Rosenberg self-esteem is the only one less than 0.05. So the correct answer is 3. And I asked what is R squared for white and black in table 5. So again, if you notice, the R squared is reported in the note table. So I just want to make sure you'll be able to read the table in the manuscript. So and the other manuscript I asked you to look at it was what the question was sort of what a statistical test we used. That was Pearson correlation for table 2. If you look at table 2, it's just talking about the correlation. It tells you the heading basically. And the other question was the correlation factor 1 and factor 4. So if you look at this is our factor 4 and factor 1 is 0.53. So that was the correct answer.